Welcome back to the Jumpstart. Today we're talking about building Linux and open source solutions on Azure. My name is Rick Claus. I'm your host today. And for the last session, we've saved the best for last. We're bringing in Madden, who's going to be in here talking a little about is it building your own platform as a service on top of Azure?
That's correct. Platform as a service is, it's been a foreign concept for IT pros and operations to a certain extent, in that there are so many definitions of what platform as a service is. So what I'm going to talk about is how do you implement existing platform as a services that are available in the open source ecosystem on top of Azure.
Okay. Just a little bit of a reminder from a housekeeping perspective. If you are interested, you can ask us some questions inside the Q&A area. If you're watching this live, if you're watching this on demand, so fortunately you can't ask us questions, but at the very first module I did actually leave up a user voice form that you can go off to, which the compute team that you're part of goes ahead and monitors quite easily, just under feedback.azure.com, and then browse around to find the Azure Compute resources to be able to go off and ask questions and also make some comments there. But I'm interested because I'm familiar with the PaaS platform perspective for the one that runs natively on top of Azure. So this is new to me. Why don't you get started and show me what's going on here for this one.
Sounds good. So in terms of the agenda, it's pretty simple. We want to first talk about a terminology, so we are all grounded on what platform as a service means. And typically you would see me refer to a PaaS, which is not a platform as a service, it's application platform as a service. It's a good way to kind of turn focus into what platform as a service is actually delivering, which is to make application deployment and management as easy as possible. We'll talk about how it relates to Linux and then to Azure, which is obviously the core topic. And then we'll talk about what Azure services today that helps you in terms of building an infrastructure substrate for enabling both first-party and third-party platform as a service, both open and proprietary. And then the last one is I would take you to a tour of different third-party platform as a service options that are available in Azure, all of them on Linux. I have a couple that that I'll talk about on Windows, but mostly on Linux.
Very cool.
All right, so let's get started. So what is an application platform as a service, right? This is my attempt to kind of simplify it to the core, right? So there are three deployment models that most of you are familiar with. Infrastructure as a service, the way you want to think about infrastructure as a service is you're migrating to it. It's basically vanilla virtual machines. You have your applications written for on-premises, running within a single machine or a set of machines, physical or virtual. And then when you move it to any type of cloud, public cloud, private cloud, it's typically virtualized, right? So everybody knows that this is the predominant deployment fashion today. Application platform as a service layers on top of infrastructure as a service, where you don't have to worry about managing the VM infrastructure. Your focus is all about building on top of it, which means you're focused on application deployment. You're actually focused on developing applications, and then you call a bunch of APIs and say, go deploy this application for me. Go manage the life cycle of the application, rollouts, upgrades, the whole 9 yards. And there is VMs involved underneath, but you are not actively managing it. And then software as a service is pretty simple. You're just using it. If you're going to Outlook.com or any of the the email services, is a great example, right? You don't have to do any bootstrapping of the infrastructure. You just use it, right? So the action verbs here, the migrate, build, and use essentially layers how our worldview is in terms of explaining what platform as a service is relative to the other two deployment models. Now, if you were to think about what that means for an IT pro, we are going through a transformation of sorts, right? And this is fueled by the advantages that cloud offers, right? The economies of scale. So we are going through a transformation where applications was built for servers, right? Physical servers. And that's a full stack server that you see in the slide, with infrastructure, compute, storage, and networking. And then you have operating system services, Windows or Linux. And then you do a bunch of clustering, queuing, and brokering options if you use multiple servers. And your application layers on top of it, right? And typically, the scale of this set of applications, you're running on tens of servers, right? Sometimes a little large, but typically it's around tens of servers. Now, we are going through a transformation where, everything is built around microservices, right? So Ross talked about it, Kundana talked about it as well in the earlier session, where, services are built for tremendous scale. And we are talking thousands of, interoperating services that are talking to each other in a specific set of protocol, right? So The infrastructure remains the same. From an Azure terminology point of view, we have Azure Stack and Azure, public Azure. So we have a consistent promise of wherever you deploy on Azure, your IT pro experience and a developer experience is the same. And then on top of it, what we had on premises as the operating system infrastructure is the VM and container infrastructure, right? So this is your large scale, hyperscale compute services that we offer from Azure, the infrastructure as a service and the platform as a service. And on top of that, you do the typical middleware, except it's at cloud scale, right? You do clustering of virtual machines, you do messaging, brokering, and it can support all runtimes. Pick your runtime, right? .NET, Java, PHP, Python, Ruby, Go, all the languages are supported. And then you build services on top of it into small, composable, independent units. And you wrap it around with the set of DevOps tooling, the stuff that both Kundana and Ross talked about, through Docker and Chef and Puppet and all the good ecosystem tools that support around it. And you need that because when you operate at a scale of thousands of services, failure is something that you have to manage at scale, right? You assume that there is failure happening in one of these services. You build logic, you build infrastructure as a code, just like how you would consider application code, right? So in order to kind of achieve that, you have to think declaratively express what you want in your environment, what you want, operating on top of your environment, right? The application manifest and so on and so forth. So this is fundamental to what platform as a service is. The server to services and in lieu of that, it's essentially implying the scale, the massive scale that you have to operate. So what are the patterns? There are a few patterns that application platform as a service uniquely identifies with, right? And I've kind of identified the key distinguishing patterns. Elastic is this notion of I want to be able to scale transparently from 0 to 1,000, right? You are building for a cloud environment and you are building cloud native apps that are essentially taking advantage of the cloud economics, both in terms of pricing elasticity. So you only pay for what you use. And also you're also keeping up with customer demand. Say you're writing an app, a mobile app or a social media app, and it takes off like wildfire. You want to make sure that you have the scale in terms of the infrastructure to be able to support that. Your application can also scale, right? So that's the notion of elasticity, very important, right? This is a key design point for any platform as a service layer. Declarative, I talked about it. At the scale that we operate, it's almost impossible to go and talk about each of these virtual machines as if they are individual unique entities. They are doing useful work for you, but at the scale that we operate, thousands of them, you're not going to go and name each of these virtual machines uniquely, have specific properties, right? In general, these are a pool or a bank of virtual machines that you use as pool of resources, compute, networking, and storage, and you want to express everything as code. This is the infrastructure as code or code as config that Kundana talked about in the previous module. Stateless and stateful. Obviously, the platform as a service, you want to be able to support both stateful applications like the database applications. All applications store data either externalized or internalized to the same application. You want the service platform as a service layer to support stateful applications. Stateless applications, ideal for web front ends, anything that requires a large amount of caching, right? So both needs to be supported. That's an important requirement. Automate everything is this notion of again, in the scales that we are talking about with thousands of services. If you don't automate, the resiliency of your manual operations fail at when you cross over hundreds. Right? If you were to write the same script or execute the same script 100 times, and if it fails, even 1% of the time, it's a management nightmare, right? And last but not the least, this notion of containers that Ross talked about in the previous module, and how it enables agility through a platform as a service layer is an important distinguishing characteristics of a platform as a service pattern, and it spans Windows and Linux, right? So these are kind of the key patterns, and what I would do is as I walk through the rest of the module, both in demos as well as talking about first-party offerings and third-party offerings, I would kind of highlight which of these patterns these offerings have available at this point. All right, so how does it matter? How does it relate to Linux and how does it relate to Azure, right? So in terms of the continuum that we have in the Azure services, we like to think of the IaaS PaaS spectrum as one that is operating under two value propositions, right? The dial is IaaS, infrastructure as a service, provides you ultimate control, and a control that you want because your enterprise requirements require it. And then on the other end is the platform as a service, where you have to relinquish control at the trade-off of gaining agility, tremendous agility in some cases, and lowering costs, right? So it's a balance. There is no one spectrum that is right for everyone. Every application and service and IT environment determines what's best for them, right? Depending on whether it's a new application, an existing application, so on and so forth. So if you plot the spectrum with the Azure services, you have virtual machines on your left. This is where you get ultimate control. You can run Linux or Windows. And then if you kind of step through the spectrum, we have this technology called VM extensions and containers that allows you to essentially compartmentalize what is running within the virtual machine, right? Like think of it as a OS level virtualization and customization that allows you to do automation on every single thing that you would do within the virtual machine and outside the virtual machine at large scale. And then if you take one further step, we have a new service that we announced at our Build conference called VM Scale Sets, and I'll talk about what that is. And the primary purpose of that service is to enable extreme elasticity, while not compromising on the declarative nature of expressing large services. So VM Scale Sets ends up being the foundational substrate of how we would actually cater to first-party platform as a service, as well as some third-party platform as a service. And on the extreme end, on the other end of the spectrum with PaaS is our first-party services, Service Fabric, and I'll touch on it. We have Azure Web Sites, Azure DB, which supports stateless and stateful applications. So this is the spectrum, and I'll kind of walk through some of the key foundational services that allows you to kind of host both first-party services and third-party services. Oops. So let's kind of talk through first about how we build virtual machines, right? Just as a baseline reference. So when you have to build virtual machine in Azure, you essentially kind of create this notion of a resource group under Azure Resource Manager, and you end up creating few resources. You want a public IP so you can reach out to the VM. You create a virtual network, and you create one or multiple subnets, so you have isolation in terms of networking. And then you have a storage account, so you can actually persist the data that is written out of the virtual machine. And then you have a network address card that can actually assign and bind to the public IP address. You can have more than one if you want. And then the virtual machine itself, right? So as you can see in the slide, we have multiple components that essentially compose and create what would look like a useful compute service for you. Before you can actually do work, you need to kind of put these ingredients together and create a virtual machines. Now imagine you are wanting to operate at large scale, say hundreds of virtual machines. We have a construct in Azure called resource loops, where you define what we call as a scale unit, essentially your loop, where you're saying, look, I want this application tier. It has a front end, a mid tier, and a back end. Each of the tiers probably has one or two virtual machines. And in the picture I'm showing you, give a simple example, right? This particular app tier has 3 virtual machines, maybe a front end, a mid tier, and a back end, right? What you could do is you could wrap this around and as a resource, and then essentially do loops on it, just like a for loop that you would do, right? And then what the Azure Resource Manager would do can do orchestration on these loops, essentially do deployment orchestration, creating tens of these, even if hundreds of these, right? So this makes it easy for you to kind of stamp out what we would call as scale units, right? If you want, right, 10 copies of this application, right, each having its own front end, mid tier, back end, it's very easy for you to kind of do that in Azure. And it's all done declaratively. This is literally a JSON file. You can consider it as an infrastructure as a code manifestation. You check in a source code repository, you version it, and all the goodness that you get out of that kind of a system. The link that is in the slide gives you a good example of what such a template would look like, right? It essentially creates a bunch of VMs, each with a virtual network, in order to kind of create a large number of virtual machines.
And obviously inside that template, you're not duplicating absolutely everything. Like in this example here, you don't need to have duplicate subnets. You don't need to have duplicate VNets and that sort of stuff. It's only the pieces you need to have.
That's correct. Really. From an IT pro point of view, the control is totally to you in terms of what gets, I guess, replicated in terms of the deployment and what is shared, right? So we have a key construct that's a lot of flexibility in terms of how you kind of compose this topology that you want. All right, so the next step is, this is great, but there are some drawbacks, right? Even this, you can imagine you're writing a script, you're running it for 1,000 times, things can fail, things will fail, right? And this is where when you operate beyond, tens or hundreds, when you get into the thousands, where you have containerized, microservices, we want another concept, and this is where VM scale set comes in, right? VM scale sets, if you're familiar with what Azure offers today, Azure has this cloud service called a worker role, which is a compute platform as a service. We are essentially re-implementing the worker role, so it actually natively supports Linux. So that's essentially what is called as VM scale sets. And the key primitives for the VM scale sets is it supports auto scale natively. So, and I'll give you an example of what this looks like. Through a simple JSON file where you're creating a single VM scale sets, in a single API, you can create 1,000 of them, as opposed to creating 1,000 VMs through a loop or individually, right? So this makes creation of large scale sets simple, but also further scaling out and scaling in much easier. Once you create, and I'll show a quick demo of this, once you create this virtual machine scale sets, auto scale becomes a programmatic API that you can say, look, I'm not using my 1,000 VMs, I want to come down to 10. You could do that, right? Just a single API call, the platform would do the right things without compromising on availability. It's obviously performant. It's meant for such large-scale operations. So wherever you're building a service, like platform as a service, that requires a bank of virtual machines that needs to elastically scale, that this is the prime focus of this particular service. It's customizable. You can run Linux, Windows. You can bring your own custom images, something that most platform as a service don't allow today. So that's the differentiating value part. A lot of the PaaS platforms, including our own first-party platform as a service, builds on top of this layer. So it's a critical step. Whatever our first-party platform as a service builds on is exactly what third-party services would use at. No difference, right? It's the same API. And last but not the least is management, right? Today, if you have to create multiple virtual machines, you have to manage the storage accounts, especially when you run out of the capacity of the storage account, you would have to kind of manage the capacity planning, right? In the case of VM scale sets, we will have a managed storage account or a virtualized storage account offering. So this independently scales. So when you do an auto scale, you just change the instance count and everything is taken care for you. This is actively in development. And if you look at the slide, the representation of the same example that I showed in the previous couple of slides would look like you would have a single API that describes what a VM scale set is. These are identical VMs. Every VM in the scale sets are identical, and that is how the platform is able to rapidly scale out and scale in, right? They share the same model. They obviously have independent lifetimes. Each VM can run as long as it wants to run, but they all look alike, right? Every time you provision a new set of virtual machines because you want to scale out more, they will all be clones of the same master configuration. Mm-hmm. And same applies for network resources, storage resources, and even extensions. This is a service that was announced. It's actively in development. The reason we are talking about it is so we can introduce what this looks like for Linux platform as a service. All right, so let me kind of show you a quick demo. What I wanted to show here is actually, because this is an active development, I'm going to run through a video and I kind of walk through what this looks like. So we have in a public GitHub an example template file that actually talks about what VM scale sets looks like. So we have defined a virtual machine scale sets template that you see in the screen, and you can see that being highlighted. And it takes in a parameter that says which location I want to create this VM scale sets, right? And VM scale sets, and in this case, it's going to be created in whatever parameter, maybe West US. And then it takes another parameter called target instance count. This is where you would specify how many instances, right? If I want 1,000 VM scale set, you would say 1,000 here. And once you define this template, in the previous modules, the examples that we talked about, the rest of it is exactly the same. In this case, we are passing a custom data. It's a Linux virtual machine. You could do that here as well. Literally every single thing that you could do on a virtual machine, you could do it on a VM scale set instance. And this is the common configuration that you will have. And I'm also creating a master virtual machine. In this case, what I'm really doing is I'm actually creating a Mesos cluster. It has a single master, which is a virtual machine, and a slave, a set of slaves. In this case, I'm going to create 20 slaves, all using the virtual machine scale sets. So what we are doing now is we are deploying a template that we just show, and through the portal. We've seen this demoed in the previous module. So we'll quickly look at the template here, and the template is essentially showing the same exact JSON file that you saw. If you want to make edits, you could do that. No difference. We are going to show, and then now we're going to do the actual parameter configuration here. So we're going to say the number of slaves we want for this Mesos cluster is 20, and we want to deploy it in East Asia. So we say okay. We can make changes in the subscription. You can create a new resource group. In this case, we'll create a new resource group. Let's call it Mesos. And then Mesos scale set. And then once we do the legal terms review, you say buy, even though in this case, you're getting free software that is running on compute. And then you do a create, and that's it. So basically what's going on right now is we've deployed the template with this configuration. Now, I'll cut right to a template that I've already deployed, right? So in this case, we've already deployed this. And you can see in the resource group view, it has created a bunch of resources. There is a master 0, which is basically a single virtual machine that acts as a master. So we're going to log into that. So we're going to quickly grab the IP address. And we're going to go see if we can get the fully qualified domain name for that IP address. And there you go. Say allow access. We cut and paste. And then let's go hit that IP, see what we see. What you would expect to see is basically the master is essentially hosting a Mesos interface, and that's exactly what you see. There's basically a master, and it's saying the name of the scale sets is Mesos scale sets, and it is saying that it has 20 VMs as slaves. This is what we created through the virtual machine scale set. And here's an expanded view of all the 20 virtual machines. They are all named in a particular pattern, by VM scale sets. And then now what we want to show is let's kind of do a scale in action, right? Let's show you how easy it is to scale in from say 20 slaves to, I don't know, maybe 10. So I go back to another template. This is a smaller snippet of the template, and you'll see quickly that once we get past the parameters, all we are doing in this template declaratively is I am changing the instance count, right? So it's just a single instance count. Again, I'm passing to the same VM scale set right there. I'm going to set it to 10. So I save it. I click on parameters. And then I pass in the new, I have to give in the VM scale set name because this is a generic template, right? So I'm saying it's called slave set. I want the new instance count to be 10. It's in the same exact region. I want to touch it. The resource group, I have to select the right resource group that I used, right? So in this case, it'll be Mesos scale set. If you remember that, then I'm saying doing a legal review, and then go. I say go create, and this template, what it's going to do is actively doing an update on a running VM scale set which had 20 slaves to say scale in to 10, and do so without compromising on the availability. The placement of all the VMs are in an availability set, so you're not willy-nilly shooting VMs down, right? And now if you go back to the master VM, which is showing the Mesos cluster running, and let's see how many slaves, and it has 10. Pretty quick, right? Now if you were to do it all by yourself, it would have taken a long time. You're playing with scripts. If you had errors, something fails, something impacted the production, nothing of that sort, right? So real easy, and that's where the power of, so if you can go back to the slides, that's where we have the power of VM scale sets. And you can see if you're building a platform as a service that is going to use VMs as a bank of resources, and you're essentially kind of through programmatic triggers, scaling in, scaling out, you want this kind of capability, right? So what we are doing in Azure is providing this base level infrastructure to you as a customer. So regardless of whether you're using Windows, Linux, our platform as a service, third-party platform as a service, or maybe you are developing your own, you could use the same power and the infrastructure to be able to take advantage of the elastic scaling.
And because elastic scaling doesn't matter because the images are exactly identical.
Exactly.
It just knows the intelligence of how to, as you mentioned, take the machines out of commission that would not impact availability.
That is a key point. The fact that all of these are identical to each other is why the platform can do rapid scaling. It knows, in fact, because you've defined that they all share a common configuration model, you've given the platform the ability to kind of scale out and scale in. And you can change the configuration, the golden configuration as well. You can always do that. And when you do that, you would be updating that configuration in a sliced fashion, sliced approach, right? If you have 1,000 VMs and say, look, and I want to change the VM size, you don't want to go blast all the 1,000 VMs because your application is going to be down, right? So that's an important construct for platform as a service. How, if you had thousands of VMs or hundreds of VMs, how do you roll out changes without impacting the application availability? Because after all, the whole value of platform as a service is to make sure that you don't worry about the infrastructure, you worry about just the application running on top of it. So what you see in the slide now is Service Fabric. Service Fabric is Microsoft's platform as a service offering, and this was announced at Build as well. we actually have a private SDK, actually an SDK, a developer preview that is available for you to download. The link is available down. And in summary, what Service Fabric allows you to do is rapid deployment and updates, rolling updates of microservice-based applications. And these applications can be stateful, stateless, and the platform as a service allows you to provide its own replication technology, or you can bring your own replication technology. For example, if I want to run MySQL at large scale, and MySQL as a database stack has its own replication, you could do that. If you're running, I don't know, Nginx, and you're storing some state within that application, and you don't want to invest in writing state management infrastructure over large scale, you can take advantage of what Service Fabric provides. As it is available today in developer preview, it's supported on Windows and .NET only, but we are planning to support Java and Linux pretty soon, and so stay tuned. Especially that link, you want to kind of keep in touch with that link to understand when it will be available. The other important point of this platform as a service, and it's a differentiating pattern as well, is it can run on any cloud. It's Azure, obviously runs on Azure. We will have first-class integration for Azure. It will run on Azure and Azure Stack, but it could run on any cloud, your private cloud, running on Hyper-V, VMware, AWS, any cloud. Anywhere you have a bunch of virtual machines that can host this platform as a service, it can be run. All right, so if you go to the open choices that you have, and remember we talked about the IaaS PaaS spectrum. So you got Azure and Azure Stack and the infrastructure. Then we have VMs. We talked about VM scale sets. We saw the demo. We have VM extensions, containers. This is kind of like your operating system infrastructure. And then on top of it is where platform as a service layers on top of it. So gone are the days where there was a bright red line between what you would consider as infrastructure as a service and platform as a service, and there was an explicit, 10 convoluted steps for you to migrate one to the other. The worldview we have is that things are layered on top of each other, right? So you as a customer can pick which layer is best for your application, and you should be able to kind of, move the dial between this IaaS PaaS spectrum as you choose. So if you look at Service Fabric, it provides basic cluster level management, but it also provides application level interfaces for doing fancy distributed application type architecture, right? Leader election, actor framework, very, very rich capabilities that allows you to do really complex hyperscale applications. Now, on the open source side of things, we have similar technologies available. Mesos and Swarm are open source projects that allow you to do clustering of VMs, right? Basically managing lots of VMs at large scale as a single logical unit. And also you can do updates, deployments without impacting the application layer. So you could totally, plug that on top of, the VM layer that we have defined on Azure. And you also have a separate layer of orchestrators, that essentially layer on top of cluster managers like Mesos and Swarm. And examples include Cloud Foundry, Jelastic, Marathon, and Days. These are application level platform as a service orchestrators, and we'll talk about each one of them and how you can get started on that in Azure. The key principles that I would highlight is, when we approach, and if you look at the slide here, when you approach any of these third-party platform as a service layer, the principle that we approach it with is we want to do what is absolutely necessary to bootstrap these ecosystems on Azure, and then let the ecosystem shine, right? Because a lot of these ecosystems, be it Cloud Foundry or Jelastic or Marathon or Days, they have value propositions which are foundational in that you can run on any cloud. Portability and agility are very important value for those ecosystems. And from Azure point of view, we totally respect that, and we want to make sure that if these ecosystems have DevOps tooling, CLI tooling, even visualization, they should just work on Azure without any changes. So our focus, in fact, even in the demos that I'm going to show you, is what do you need to do to just get the ecosystem bootstrapped for Azure? And after that, if you're a Cloud Foundry user, use the Cloud Foundry tooling. If you're using, Jelastic or Marathon or Days, that ecosystem just takes them. You don't even know that the backend is running on Azure. That's an important point because, we want to take advantage of all the innovation that's happening on these open source projects, right? So let's talk through a few of these examples. I'll show a couple of demos as well. Cloud Foundry is an open source platform as a service that essentially allows customers to actually have multi-cloud platform as a service implementation. Whether you're running on a public cloud, Amazon, Google, Azure, or any other public cloud, private cloud, running on whatever hypervisor infrastructure, or hosted infrastructure. Cloud Foundry is the platform as a service layer that focuses on being able to interoperate between these different clouds. So as a developer or a sysadmin, I really don't have to worry about how the underlying infrastructure is implemented across these different environments. You can just focus on the interface to Cloud Foundry, and you deploy your applications, and everything else is taken care by the Cloud Foundry. So the work that we've done for Cloud Foundry and Azure, we worked on the open source version of Cloud Foundry. And Cloud Foundry has what we call as the cloud provider interface. This is basically the API infrastructure that they've implemented that will abstract the differences between different clouds. So we've implemented a CPI for Azure, and this is in public preview at this point. If you look at the link, it's the blog that has the information on where the GitHub locations are, and you can actually try that out yourself. So it supports a variety of common runtimes and languages as you would expect from a platform as a service: Java, Python, Ruby, PHP, Node, and Go. And like I mentioned, the two simple steps is you bootstrap the ecosystem on Azure, and then you go right on. So let me show you a quick example of what this looks like. So if you go to azure.com, so basically I went to azure.com, I clicked on community, and I went to templates, and then it's loading now. And we have hundreds of templates here for folks to get started. Both Kundana and Ross talked about templates, so I won't spend a whole lot of time. What I'm going to focus on is how do I get Bootstrap for using Cloud Foundry and Azure. So I'm going to search for BOSH. BOSH is the command line interface or the framework for creating Cloud Foundry compatible interfaces, and we have created one for Azure. So again, as you can imagine, this is basically a template in itself. It's in GitHub. Anybody can go take a look at it if you want. But I'm going to skip that and just do a deployment, right? It's the same thing that you saw in the previous demos. It's going to log me in, suck the template, from GitHub, and you can basically go edit the template as you need to. And what you would see here is it's creating a bunch of IP addresses, a virtual machine that will essentially act as your client virtual machine for deploying into Cloud Foundry. So what I'm going to do is I'm going to do just do a save. I can edit the parameters that I want. It's going to ask you like, hey, what's the storage account that you want to create for this client VM that you're creating? What's the username, password, which location you want to create, VM size, VM name, so on and so forth. So I've already done that, because obviously, deploying the infrastructure takes a bit of a time. So what I'm going to do is I'm going to go to a deployment that I already have. So what I'm doing now is I'm exploring to see if I can go look at my resource groups. And then I'm going to search for Cloud Foundry. And there we go. And this is a resource group. This is basically a template that is now deployed. It's already running. So you can see that I have a virtual machine called Madan CF Demo VM. This is my client VM, and I'll SSH into the VM and show what's going on. And then I have various resources, a NIC, a bunch of IP addresses. I've created 4 IP addresses because I know a Cloud Foundry deployment requires this infrastructure. I'm upfront creating them. I'm creating a virtual network, for network isolation, and then I'm creating a storage account, right? So it's all deployed. So let's log into the client VM. So if I go here, this is the Cloud Foundry Demo VM. Remember, we saw Madan CF Demo VM. I've logged into the VM. And if I type in BOSH, the entire tool set is already bootstrapped, right? So now I have all the things that I would need to get going with BOSH. BOSH is, like I said, the command line interface for doing, deploying some of the Cloud Foundry, what you call as a micro BOSH. So the only thing that you would have to do after you, created this VM, after the template is deployed, you go into this file, and you basically edit it for making sure that it has the right authorization privileges to access your resources that you created on Azure. So what I'm doing here is I'm basically giving it, the tenant ID information. This is, for my subscription, I have a tenant ID for the deployment. And then I'm giving it a password. I'm not filling the password obviously here, but setting a password. And then the client ID is basically the service principal. This is the, the authentication token by which this tool, right, this client VM using BOSH would manage my Azure resources, specifically Cloud Foundry. I edit this file. And then I just do, I think I did a, I look at, that's it. So I just have to do a BOSH micro deployment, micro BOSH the YAML file that you did, and that's it. the deployment is set up, I would actually end up with the creation of a micro BOSH VM. And then from that point onwards, you do exactly what you do with Cloud Foundry on any cloud. You're up and going. So very simple. So I think the point of the whole demo is we've tried to kind of keep the infrastructure integration as easy as possible from a customer point of view. Through a template, it takes you just a few minutes to get up and going, and then whatever you're used to as a Cloud Foundry developer, you can just get going. All the value that you get out of Cloud Foundry, with the ability to kind of scale on demand, ability to deploy application, build an application, and stay at the application layer. You're able to do that. We talked about the demos. I'll skip this slide. The next platform as a service offering that we worked with is called Jelastic. Jelastic is short form for Java Elastic. So as you can imagine, it's the platform as a service layer that emphasizes importance of Java apps to be run in a platform as a service layer fashion. The screenshot that you see is from an Azure Marketplace. This is available in Azure Marketplace. If you go search for Jelastic, you will see it. Even though it's called Java Elastic, it actually supports a wide variety of runtime. In fact, it's one of the platform as a service offerings that actually supports Windows and Linux runtimes. So it has .NET Windows, Java, Node, Ruby, Python, the usual suspects that you would imagine, right? And our support in Azure, when we worked with Jelastic integration, it comes in two configuration modes. One is called Jelastic Virtual Private Cloud. And what this does is, you can have a platform as a service that lives in Azure, right? So you're not connecting to any on-premises infrastructure. It's completely cloud-based. And it could be multiple regions, but say you're essentially creating a platform as a service layer in one of the Azure regions. You can just go to that image. It's essentially a template. It'll deploy the template, and you would have all the information that you need. Just get going, right? So again, the bootstrapping is very simple. It's template-based. It's declarative. Once it's deployed, if you're used to Jelastic, whatever tools and interfaces that you have, you can continue to go. The second mode is what we call Jelastic Hybrid Cloud. And this is where if you're a Jelastic user and you have a big on-premises footprint and you want to expand Jelastic to manage a bunch of Azure virtual machines, right? And this, again, is we have a set of steps. We have the link to the documentation on how to kind of bootstrap the ecosystem. So you can actually burst into capacity in Azure in any region, one region or multiple regions. So we made it very easy for you to kind of get going if you're a Jelastic user. So again, this is one of the platforms as a service layer today that supports Windows and Linux, and you should be able to get started pretty quickly. All right, let's talk about Marathon and Mesos. So Marathon and Mesos, it's a platform as a service offering that essentially kind of wraps around a tool set called Data Center Operating System. It's called DCOS. This is something that we did the integration work and announced at Build as well. It was part of actually the Build keynote, if you remember that. It's a solution that's put together based on open source components, right? So it has Mesos, which I mentioned, is the cluster manager. It manages a large number of virtual machines, up to thousands. And then it has a scheduler, a work scheduler framework, right? So you can actually dispense work for it to do work, right? If you're a batch application or if you're a database application, long-running workloads, small-running workloads. Marathon typically runs short-running workloads. There is another scheduler called Chronos. They have different schedulers that can compose on top of Mesos. In fact, if you remember, the demo that I showed on VM scale sets essentially bootstrapped a base level Mesos infrastructure. And it supports all the things that you would expect in terms of the platform as a service pattern, right? Auto scaling, the fact that it's using containers, a lot of the container-based microservices is built on top of a Marathon Mesos today. It is capable of supporting other schedulers. They have a plugin framework where if you want to write your own scheduler or if you want to use an industry standard scheduler like Yarn, for example, for data applications, you could do that. It only supports Linux today because obviously it was born out of open source ecosystem, and early access is available. So I'm going to go show a quick demo if we can switch to my screen. Here is basically the documentation from the Mesos website that we worked together. It shows you step-by-step information on how to get going with bootstrapping a DCOS cluster on Azure. And it's again, we see the template example again. So what I'm going to do is copy the location. So this is basically a direct sign-in link if I'm a portal user. So I'm going to go here. I'm going to custom paste that. It gives me access to the early access template that we worked with the Mesosphere folks. And what you're going to see is that template is going to be sucked in, and you will see that it is essentially creating a bunch of virtual machines, right? Bootstrapping the ecosystem for Azure. So again, the Mesos tooling can easily take on. So if I kind of go through the template, you will see that we're creating a bunch of network resources. You have a network security group. You have virtual networks. And if I scroll down deeply, you have NICs. You have virtual machines. In this case, they are using a resource loop. Remember in my previous demo, I used VM Scalesys. They are using resource loops here. They're passing a whole bunch of custom data to do kind of bootstrap the specific set of virtual machines. All this is doing, this big custom data is doing is making sure that the slave can talk to the master.
Oh, okay.
This is master. And then if you kind of keep going, you have a bunch of other things that are getting bootstrapped. I can do the edit of the parameters. I just cut and paste my public key. If I want internet access or if I want to use a specific subnet, if you want to keep outside of internet access, and then the region. So I actually created one already for the sake of time. So I'm going to go browse my resource groups so I can quickly look up what I had created. So if I can find R. And you'll see the first one is actually the DCOS demo that I created. So yes, you can see the single template is actually creating a whole bunch of resources. It's actually created an availability set, because obviously it's a highly available platform as a service layer called masters. It has one master, master 0, and then it has about 5 slaves, right? In my previous example with VM Scalesys, I created 20. In this case, it created 5. It has a master node NIC and a slave node NIC. And the NIC essentially kind of floats around, right? Now, what I can do is, this is all set up. I just have to grab the IP or the fully qualified domain name of the master. And then I can hit that IP address and see what that looks like. So I've got the IP address, and let me get the fully qualified domain name. Actually, I should have looked at the IP address. I got this here. So you can see the the fully qualified domain name is master0 DCOS demo. That was the name of the resource group. It's in East US, and I'm just hitting that VM. And let me refresh the VM so we can get the master VM, and the dashboard is showing. Now, essentially, I've got the infrastructure bootstrap. I've got the dashboard. It shows me all the resources, how they're allocated, what's the failure rate. I haven't deployed anything here. I have 5 nodes, I have a bunch of capacity. So I'm going to go look at, let's see if I can take a look at, I can go, Marathon is my scheduler. This is how I would deploy an application. So I click on Marathon. Then I'm ready to go. I can say new application, and provide an ID, number of CPUs that I want. Look at this, the fine-grained, granular CPU slicing that you can do, right? You can do it in decimals. Then the memory that you want for each of your application, all the settings, the command that you want to run on, across the different slaves that you have. And that's it. You fill this, you're up and going. You literally didn't have to worry about managing the infrastructure, patching that VM, what version of operating system, what NICs. All of that is taken care for you just by deploying the template. So that's essentially the power of the infrastructure that we are developing for enabling third-party PaaS. So if we can go back to the slides, this is available in early access. You can take a look at that link below. This is the actual documentation link from Mesos for you to get early access, and you can just get going, just like how I did it. It just takes me a few minutes. We talked about this. Days is the last option that I'm going to talk about in the module today. Days is also an open source platform as a service layer, very specifically built for container-based microservices, right? So as you can imagine, if you are creating a large distributed multi-container application running on containers that Ross talked about in detail, you really don't want to be in the business of actually going and figuring out how many virtual machines you need, and when your application scales, how many more virtual machines you need to add and manage and patch. Days takes care of that for you, right? So it's basically you focus on application that happens to run in containers, and that's the only concern that you need to worry about. It can deploy any application or service that can run inside a Docker container, right? Literally anything that can run in a Docker container, Days can orchestrate for you. And obviously it can auto-scale, it can do all the characteristics of what a platform as a service layer. It even has full integration with continuous integration, continuous deployment tooling ecosystems, right? The popular ecosystems that you support them, Jenkins, TeamCity, they are all built now to kind of work with Docker containers. So, they should be able to just interoperate with that. And the picture here is right from our documentation. You see the documentation links that tells you how to go about, bootstrapping the day's infrastructure step by step. Again, true to our principle, we've tried to kind of keep the infrastructure integration to just enough so you can get going quickly using the Days toolset, right? In Days lingo, we essentially create a router, a builder, a controller, and once you set this up on Azure, you're speaking in Days lingo, right? Again, take a look at this documentation. There is a template for you to get started. You can change the template to whatever you want, but we make it quite easy for you to get going. So in summary, from a platform as a service layer point of view, there are 3 value propositions for you, right? You want developer agility, right? You get developer agility by not having to manage the VM infrastructure, right? And how do you do that without compromising on compatibility, without compromising on control, right? The only way to do that is to kind of build a layer like this, right? You have a bunch of virtual machines, a bank of virtual machines. In our case, we'll use VM scale sets. And then you deploy a bunch of containers on top of it. You can use, Mesosphere or Days or any of these scheduler frameworks. And then your application runs on these containers. So this is kind of the ideal North Star that all of us are going towards. And this model should be portable. So regardless of which infrastructure you're running in, private cloud, any public cloud, hosted private cloud, Windows or Linux, you want to be able to kind of move around. And then you want the elasticity, right? That's the true promise of cloud. The economies of scale in the cloud allows you to only pay for just what you use and rapidly scale out and scale in without having to worry about how much hardware you need, how much VMs you need, right? Your focus stays on just building the application, deploying the application, and maintaining the health of the application, and then growing out and growing in. So the animation we have here shows like if your application grows like wildfire, you want it to declaratively communicate to the group of containers, right? The PaaS layer, whether it's Mesos, Marathon, or Days, to say, hey, I want 1,000 more containers, which should then declaratively talk to the VM infrastructure, right? In our case, it will be VM scale sets to say, I want 100 more or 100 less, right? You don't want to be in the business of managing, how many VMs to add or how many containers to add. So that's essentially what we are going after, and that's the value proposition that you get in Azure. So the key takeaways I would say is you can do, application platform as a service on Linux and on Azure. There are many open source options available. We obviously have a first party, with Service Fabric as well. We'll have Linux support soon. But you pick your layer, platform as a service layer, and you can bring it to Azure. Integration, as I mentioned, we want to make sure it's super easy for you to kind of bootstrap the Azure infrastructure and then continue to use your tooling, right? The tooling of choice, whether it's Marathon, whether it's Cloud Foundry, any of these can work. And then the second takeaway is, pay attention to the scale aspect. Elasticity, right? Elasticity is the key design point for platform as a service layer. If increasing scale, by 100,000 means that you would have to do more work, it's likely not pass, right? So a lot of the options that we talked about today, they truly emulate what is needed for, auto scaling, right? So your application doesn't have to worry about going and talking about, I need to have 3 more NICs, 4 more NICs, and you go deploy, something fails. You really don't want to get into that business if you're focusing on PaaS.
Now with these solutions here, you mentioned being able to increase and decrease the different numbers of roles underneath it to be able to get your scale and sort of stuff. What about patching and updating of those individual ones?
That's a great question. So there are 2 layers of application management, right? So I'm writing an application, maybe a PHP application or a Python application running on, say, hundreds of VMs or hundreds of containers running on hundreds of VMs. As a developer and IT pro, I am responsible for the application health. So application updates, application role, rolling updates, application deployments, application scale is something that I should be concerned with, right? Now, when I do those activities, I also have to make sure that the VM infrastructure underneath is also up to date, right? And in fact, you don't want a VM infrastructure to do an updates at the same time as an application, right? And this is what the platform as a service layer allows you to do. It declaratively communicates with the VM layer underneath, so the VM layer can be managed automatically, right? If you get a new version of Linux OS, whatever version of Linux distribution you're running, when you do apply the patches, you can do it independent of the application. And you do it so that your application is not suffering a downtime, right? So you are freed from the responsibility at the groups of VMs layer. Your focus is only on the application, right? In fact, it even goes beyond, the VM layer, right? The hardware itself that we are running at our scale in Azure hyperscale, we update that as well. So there are declarative communication channels in each of these layers. So when you are worried about managing the application infrastructure, you don't have to worry about the rest. And you can do that only if you can declaratively express what your intent is with application update.
So it selectively goes in and, as you mentioned, brings in new ones, takes old ones out,
That's correct.
and then the application layer runs on top of that. You don't worry about that because it continues to work.
That's right. Every update, especially at this large scale, you always want to do a slice-based update, which means you would actually define, say if I have, 150 containers, you would say what your definition of slice is. And you would say, I can't update a new application in more than 10% of my footprint, which is 150, you get 15 at a time. And you try out your new application on 15, see if everything is good, application health-wise, and if it's good, you roll forward. If not, you roll back, right? So these primitives are built foundational to our VM infrastructure. So the VM scale set infrastructure that I demoed actually has an update API where you can pass in the percentage of VMs you want to update with a new version of OS or a new configuration chain, new VM size, you name it, right? And if you do care about updating all of them at the same time, maybe you're a batch application, you don't care about application availability, you could do that too. We give all the primitives to the user, so third-party platform as a services and first-party platform as a service has the full power to implement whatever policies they want on top of it. Yeah.
Very good. Any closing thoughts, or is this a Shami that you're all good with?
Yes. Yeah. So let me see. I think that's the last one.
On there.
I guess I was going to show if we can show quickly the documentation that we have.
Yeah.
If you want to, go look at the documentation to get started, I would encourage you guys to go take a look at all our documentation. The links are in the slides, and give us feedback. If there is something missing, we would love to know.
Yeah.
We'd love to learn.
It's like I remember that particular documentation side of things. Obviously, it's all available on GitHub to be able to go off and to clone your own options of it, make updates, and even contribute back to it. And then those pull requests get evaluated by the subject matter expert to see if they're able to come in or not. Don't forget, any of these things we're looking at today, you're able to go off and to download the slide deck with all those lovely resources that you have inside of there. If you're watching this on demand, it's one of those resources that are available as part of the course from Microsoft Virtual Academy. If you're still here for the last little bit that is still live, then obviously it's available under the FAQ. The biggest thing that's common across all these different sessions today so far is obviously go out and try it. Go to Azure.com, click on that free trial to go off and to try that environment and to sign up for a subscription. It requires a credit card for identification purposes to be able to ensure that you're up and working correctly. If you're actually from a university or student perspective, you actually have access to resources through your different subscriptions that way as well, through DreamSpark and through, I don't remember the names of those programs, they change all the time for what they happen to be, but DreamSpark gives you access to it as well. And one of the easiest ways I find is actually if you have an organization that has an MSDN subscription, you can obviously go through and activate your benefits to go off and try those right now. But Madden, we're slightly over time, but still on time. So I want to say thank you very much for joining us. It was a great way to end this last session. Thank you very much in the back there.
And thanks for joining us live.
Yes, definitely for sure. In case you are still listening, we will be having this available probably within the next couple of weeks, available on demand on MicrosoftVirtualAcademy.com. I'm Rick Claus. I was your host today. Had a lot of fun, and I'll see you next time.
All right, thank you.